So t squared, the square of the period, is equal to 4 pi squared I here divided by mgx. Later, the next year, not this year, you will learn that this I is called the moment of inertia. But next year, okay? Moment of inertia. So I have just waited to remove the square root sign, okay? Next thing, we consider the unit. The unit of t squared, the square period, is second square. Second square. And the 4 pi square here is just a constant, a value which has no unit, okay? No unit. And here I need to find the unit of I, the dimension of I. The unit of the mass, and big N here, just like the small n, it is the mass, and therefore its unit is kilogram, okay? G is meter per second square, just use it directly, meter per second square, okay? And the height, h here, unit is meter. So from this equation, it's like A equal B over C. The thing here on the top is B. Everything at the bottom is C. So the unit of I is second square here. Taking A multiplied with C. Second square multiplied with kilogram meter square. Meter times meter, that meter square. Okay? And second minus 2. So finally, the unit of I is kilogram meter square, and no second, because this is second square and this is second minus 2. Okay? So this is the final answer. The unit of I, moment inertia, is kilogram meter square. Please, write this solution on the book. Question 7, which the following correctly expresses the volt in terms of SI-based units? Okay, I'd like you to try finding the solution of this one, volt. Volt is the unit of voltage. So what is the formula of voltage? And not only the formula, but the meaning of it. What does it mean? The definition, okay? The most important thing in physics, the first thing to study physics is understanding the definition, voltage. Voltage is the work that an electric field have to provide to do the work. Work is force multiplied with displacement, and equivalent to energy. So energy is basically work, the ability to do some work, that is energy. Okay, voltage is energy to move unit charge. And what is charge? Another definition.
How?
You have a kilogram is the unit of mass for the mass, and for the charge you have the unit coulomb. And this is a derived unit, not a base unit, because the base unit is ampere for the current. Okay, this is a base unit, and the current I is defined as the charge moving through a place in a second. The ratio between the charge Q and the time. Charge over time, that is current. And therefore, with coulomb, the unit of charge, so the coulomb here is equal to ampere multiplied with second. Coulomb equal ampere second. So that is the definition of charge. And the voltage, let me change the color. Voltage is charge, work to move charge, which means this formula, the voltage is energy to work over the charge Q, and therefore its unit, the unit of voltage, is coulomb over, energy is joule, okay, over coulomb, joule over coulomb. Wow, a lot of joule over coulomb, and how we need to derive, joule and coulomb, you did that, right, in the assignment. Joule, energy is work, which is work equal force multiplied with displacement, and then force is mass times acceleration, and then times the displacement. Okay, so joule is kilogram meter per second square, and distance is meter. So I will combine the meter. Okay. Coulomb is here. Ampere second. Okay. So the final unit is kilogram meter square. Second minus 3, right? Minus 2 on the top, and then divide second again. Minus 3, and finally ampere minus 1. Oh, this one. Wow. Too complicated, huh? It's not a medium problem, it's a hard problem.